to the medium change.
Speed will change. Yes, you are right. What is the another thing?
Hmm.
Will it go straight? My question.
Uh, it'll
It won't
either
go straight.
it'll
It
diverge.
bends. It bends. Not diverge. Diverge is a different word. Here we have to use the word it bends. And the
Okay.
middle perpendicular line, imaginary line we have drawn. No, this is a normal line.
Yes.
Now you can see that light has bended towards the normal.
Yes, sir.
So now here we are having two different mediums. One is air, another one is water. And when we check the speed of light in air, the speed of light in air, we generally write the letter C. And speed of light in medium, I'm writing as a V. And we know the speed of light in vacuum is the maximum, and
Yes,
nothing
sir.
else can cross this one. And the speed of light in medium is lesser than speed of light in vacuum. This is less. The speed is less here. The speed is more here. So where the speed is more, that particular medium we need to call it as a rarer medium. The other one is denser medium.
Understood.
So now light ray is entering from rarer medium to denser medium. When light ray enters from rarer medium to denser medium, it bends towards the normal.
Yes, sir.
Okay, when light ray enters from rarer medium to denser medium, it bends towards the normal.
Yes,
Okay,
sir. Okay, sir.
now this is what the previous concept. Now, light ray is coming from air and to water. To water. Now, how it reacts here? Why? Because
Since
what is the difference? What is the difference here? What is the surface? Surface is looking plain.
hmm,
But here, what is the surface? Curved.
curved, yes, sir.
So now, what we are going to learn here, refraction of light at curved surfaces. Will it behave the same manner or different? That's what we are going to see. So, whatever the refraction, one point we learn when light ray enters from rarer medium to denser medium, it bends towards the normal. And when light ray enters from denser to rarer, opposite, it bends away from the normal. Okay, normal line is very, very, very important. And and normal, why? Because we calculate the angle of incidence, angle of refraction based on the normal line.
Yes, sir.
Okay. Now, how to draw the normal line from a point? So now, as it is curved surface, curved, it is nothing but part of circle. It's like an arc. When you complete this curved surface, it would become a circle, and
Yes, sir.
every circle would have center point.
Yes,
So,
sir.
as it is not a full circle, only simple small part of surface is there, but still we can find the center by imagining that making it a full circle. The center of this curved surface, I'm calling it a center of curvature, C. Okay, and we all know that for mirror we have written the word letter P. Here also one letter P I'm keeping the center of this particular. Now the line joining this P and center of curvature, the line joining the P and center of curvature, I'm calling it as principal axis. What is principal axis?
Principal axis is the line joining the pole, the focal length, and the curve
And
point of
center of
curvature.
curvature. Okay, here focal length not necessary, but anyhow. Now any point, any light ray which is coming towards the spherical surface, how to draw the normal for this line means this point is the point of contact and center of curvature. From center of curvature, you draw a straight line. This
Okay,
straight
sir.
line 100% normal. So where the center of curvature and point. Here you can see that these normal lines, you can draw normal lines in any direction. So now you can see that light ray is coming and this light ray is parallel to principal axis. Principal axis is this line. Now this is the point of contact. How did I draw that particular normal? I joined a line from center of curvature. So we need to draw normal line first. Why? Because remember that point when light ray enters from rarer medium to denser medium, we all know that it bends towards the normal.
Yes, sir.
So do you remember that when light ray enters from rarer to denser, air to water, the light ray bends towards the normal. Okay, here I have taken some lines which are parallel to principal axis. The outside
Yes,
atmosphere is air and the curved surface has water. And this is the principal axis. And light ray is coming like this. Now light rays entering from rarer to denser. Now how
yes,
to
sir.
draw the normal? How to draw the normal? This point and this point just to join with a straight line. Dotted lines indicates not imagination, imaginary line. Now, what is my point is this light ray which is entering from rarer to denser. Just now we have learned that light ray which is entering from rarer to denser, it bends towards the normal. Imagine if the curved surface is not there, this light ray would have go straight. If curved surface is not there, this light ray would have go straight. As curved
Yes,
surface is there, as curved surface is there, and light ray entering from rarer medium to denser medium, it bends towards the normal. Normal is in which direction? Downwards here.
upward.
So what happens? This light ray, instead of going straight, it bends towards the normal and forms a point here. In the similar manner, almost all light rays which are parallel to principal axis, they all bends towards the normal. So you can draw that particular picture. We can try. So here, what are the letters we have learned? Central curvature, pole, principal axis,
Poles,
and light
then
ray.
light
Drawing a
ray,
light
and
ray.
then
When light ray is passing from rarer medium to denser medium, it is bending towards the normal. Okay. So that is what we learn. So here, what is the answer? Uh, what happens to a ray that is incident on a curved surface separating the two medium? It is still obeying the laws of reflection. Loss of reflection means we all know that sin A by sin R is equals to
cos A by cos
constant.
constant.
So basic introduction we have learned now. Let me see. Define center of curvature and principal axis of the curved surface that you know. Why empty glass makes an object behind it look smaller? That answer you can find. What is meant by pole of contrast? How it is different from the center of curvature means pole lies on the curved surface. Center of curvature always lies outside of the surface.
Yes, sir.
Now, rules for bending, ray bending at curved surface. So, first rule is what? If a light ray is coming towards the center of curvature, it will go straight, undeviated. So, they do not deviate. What is the first rule? When light ray is coming towards the center of curvature, they undeviate. Can you remember?
Yes, sir.
Now, the second one. Just now I said, when light ray is parallel to principal axis, what happens? It bends towards the normal. So two rules we have seen. You can read here also. The light ray passing through principal axis as well as towards center of curvature. These both rays undeviated. But when light ray is parallel to principal axis, it bends towards the north. Now, what is the difference between this first diagram and second diagram? This is
Here,
what
when
you
you're
need to.
going, here, when the ray goes from the rarer medium to denser medium, it
Hmm,
it goes towards the normal, meaning I think it converges. No, no, no. It bends.
denser to
It
normal, it is moving away from the north. Here, the curved surface is concave shape, and light ray is coming from denser medium to rarer medium. That
will
is the
be
difference.
will
No,
be
no,
convex.
converge and diverge. Where do we use converge and diverge? Converge means when light rays all meet at a point. That is what meant by converge. When light rays are moving away from the point, we will
That's
call it
diverge.
as diverge. There we have to use. Here, no use of bends is required. Bending towards normal, bending away from the normal. This is the logic, only one logic you need to remember. See here, curved surface, and this is air, this is water, and center of curvature. Light ray is passing through parallel to the principal axis, and I have drawn the normal. How did I draw the normal? Just by joining the point and as well as the center of curvature. Eh, Now it bends towards the normal here. Now this
Okay.
reverse thing happens in the second picture. So please practice these two diagrams later. But I hope you understood these two diagrams. The way of drawing the ray diagram. Here the case 1, case 2 has given. Rarer to denser, and here the second one denser to rarer. What did you see here? It bends towards the normal. Here it bends away from the normal.
Normal.
Only one time practice enough, you will understand.
Okay.
This knowledge is very, very important. Anna. In this case 3 and case 4 diagram, what do you see that? Light ray is coming from denser
Like
medium to
rarer medium.
rarer. Okay. Light ray is coming from denser medium to rarer medium. So you please see this particular diagram.
Okay, sir.
This is denser one. This is rarer one. In this particular surface, light ray is coming from denser to rarer. If this curved surface is not there, how would this particular light ray would go? Light ray would go straight, undeviated. But curved surface is there. We all know that when light ray enters from denser medium to rarer medium, it should bend away from the normal. So away from the normal, it has to bend. But where is normal here? What is the line is normal? We already know that from the point of contact to the center of curvature, the line joining the point of contact to the center of curvature, this particular line is normal. So this is the normal line. Now, this light ray, if you go, you can check that. If it is drawn this side, it indicates that light is drawn towards the normal. But we all know that when light ray enters from denser to rarer, it bends away from the normal. Therefore, instead of this one, it chooses this side. It bends away from the normal. So this concept is very important. So Nana, just you try the fourth diagram. First, you draw the curved surface. Fourth one, figure 4D is there, no? In your notebook now.
Yes, sir.
And keep denser and rarer.
Okay, tensor and rarer.
Okay. Now, what is the curved surface shape? The, the 4C is the convex shape. 4D,
What is concave?
cave shape.
Concave.
So here denser, this is rarer. Now, light ray at concave surface, remember, at concave surface is going parallel to the principal axis. First point is
Yes,
what?
sir.
The light ray is going parallel to the principal axis.
Simple
Second
axis.
point is what? Meeting the concave surface. Say both the points. Light ray is parallel to
Light
the principal axis.
parallel to the
Say
principal axis.
meeting the
Light ray,
concave surface.
a light ray which is parallel to the principal axis,
Meeting the
meeting the
concave surface.
concave
Concave
surface.
surface. And going from rarer medium to denser medium. Or passing from rarer medium to denser medium.
Passing from rarer medium to denser medium.
Okay. Now we are ready. Now we all know that when light ray enters from rarer medium to denser medium, it bends away from the normal. Sorry. Rarer to denser, it bends towards the normal.
Yes, sir.
So what is our duty now? Which one is the normal line? Where I have to draw the normal? Normal, normal how I can find? So first look at the center of curvature point where it is. So this point is the fourth point. Now we are discussing about normal fifth point. This is the center of curvature and this is the point of contact. Just draw imaginary line. We mention imaginary line with dashed lines. Now this line what we have drawn is normal line. Okay, Nanan? Now you just mention when light ray is entering from rarer to denser, how it should go?
From rarer to denser, it should go away from the normal.
Hmm?
If
Will
the
it
image is,
go away from normal or
it'll go away
towards the
from the
normal?
normal. It'll go away from the
Eh,
normal.
no. Here you see that when light ray enters from denser to rarer, when light ray enters from denser to rarer. Denser to rarer, away from normal. But is the light rays entering from denser to rarer or rarer to denser? It
Light
is entering
rays
from
traveling from
rarer to
denser
denser.
to rare. Yeah, rarer to denser.
Rarer to denser. तब क्या
Yes,
होना
yes.
चाहिए? It should bend towards the normal.
Yes, sir.
Normal means, see that. Imagine that if no curved surface is there, the light ray direction is this one. इस तरफ ड्रॉ किया तो लाइट रे इज बेंडिंग अवे फ्रॉम द नॉर्मल. ऊपर ड्रॉ किया तो टुवर्ड्स द नॉर्मल, क्योंकि नॉर्मल यहाँ है ना. हियर द नॉर्मल इज. Therefore, in which direction I need to? Should I draw down? Should I draw up?
Draw up.
Because the light ray is bending towards the normal. That is what you see here.
Yes, sir.
Okay. So this particular concept is very, very important. Then the rest of the questions you can get very easily. But we need a little practice. Okay. That later we will do this practice, how to draw the ray diagrams in a separate class. So here we have learned the principal rules of drawing ray diagrams and curved surface. Let me see what we have next. Image forms. This is the curved surface, and this is the water. It means it is a denser medium. The outside is rarer medium, and this line is principal axis. Please draw these three first. What I have drawn, please draw first.
Okay, sir. Done, sir.
Then, good. Somewhere you put the point on axis as O, object. And here at some point you put center of curvature. Now one light ray you draw like this.
Done, sir.
So now I request you to please draw the normal line. How to draw the normal line? This is the center of curvature and this is the point of contact. How do we have to draw the normal line? Just put dashed line by joining those two. Put dashed line as you
Done,
can see in the picture.
done, sir.
Okay. Now imagine this is the light ray. If curved surface is not there, it would go straight. If curved surface is not there, it would go straight. But light ray is coming from rarer medium to denser medium. Therefore, when light ray is coming from rarer medium to denser medium, rarer to denser, what should happen? It should bend towards the normal.
Yes, sir.
Normal is this one. Therefore, what happens? It bends towards, instead of this one, it bends towards the normal. So where it meets, I am getting the image. Draw this one. And the last from this point, you draw a perpendicular surface.
Okay, sir.
and write n.
And
Okay. Now, your duty today is you need to identify three angles: alpha, beta, gamma, angle of incidence, and theta 2. You can see that angle between the incident ray, this one is incident ray and normal is angle of incidence. And this angle is angle of refraction. And this is alpha, this is beta, this is gamma. You can see in the picture. These five angles makes the difference. In the next class, we are going to see the derivation. So in the derivation, alpha, beta, gamma, theta 1, theta 2 makes the difference. So you should understand. Okay, Nanas, just 2 minutes. I will stop explaining. Just please draw the diagram as fast as possible. Redraw this
okay,
entire diagram, which is first you do one thing, you copy the diagram and spend some time to by heart it. And second time you draw without saying. Now itself you need to get.
okay, sir. Mm, 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 alpha, beta, gamma. Done, sir. I've highlighted it.
Good. Did you draw? So, and did you locate that three angles? Alpha, beta, gamma, and
Yes, sir.
theta 1
I'll
and
draw the
theta 2.
diagram. Yes, I'm going to draw the
Now, these
diagram.
angles are very, very important. These angles are very, very important because the derivation depends on this angle. First of all, let me try what is angle of incidence. Angle of incidence. This one is there, no? This is this line. From object, whatever the line is coming, this line is incident. So, and this ray is the normal ray. Angle between the incident ray and normal is angle of incidence.
Yes, sir.
So, angle of incidence, what did I mark as theta 1?
Theta.
Now, what is angle of refraction? Angle of refraction is angle between the refracted ray, angle between the refracted ray and normal, angle between the refracted ray and normal,
Between the refracted ray. Um, that would be
angle between the refracted ray and normal is called angle of refraction. With what letter it is denoted? Theta 2.
theta 2.
Where you can see the picture here, normal, yeah, and incident ray, this is theta 1, and normal here, and this is the refracted ray, theta 2.
Yes.
Okay, now you have to look three triangles. Triangle AON, triangle
Oh,
AON, angle at O is alpha. Now second triangle, triangle ACP, that
ACP.
is beta.
Beta.
Can you guess the third triangle?
AIP.
That's it. That's it. Now the angle AIP is graph.
That yeah, gamma.
Okay. Now another mathematical concept which is not related here. Suppose if I have drawn anything, this angle I'm going to call it as exterior angle. So exterior angle is equals to sum of opposite interior angle. That is a mathematical statement. Exterior angle is equals to sum of
Area
opposite interior
from
angles.
operating. Yes, sir.
Here theta 1 and theta 2 are exterior angles. Theta 1 is the exterior angle for triangle AOC. Theta 1 is exterior angle for triangle AOC. See that? Draw the triangle, it would make your work easy. Yeah, A, this is O, this is C. At O, we have the alpha. At C, I am having the beta. And this angle is theta 1. Exterior angle theta 1 is equals to, we all know that sum of opposite interior angles.
Sum of
This
opposite
is the
interior.
first point. Now, look at the another triangle. Look at the another triangle. This triangle I am calling it as ACI. Beta is the exterior angle here. I said wrong before. And theta 2 and gamma are the interior angles. We all know that exterior angle is equals to sum of opposite interior angles. This is 2. So today you just by had these two diagrams. These two diagrams I got from this picture only. By heart now itself. So that is the
Okay, sir.
gamma symbol. Beta is equals to theta 2 plus gamma. Get those two triangles fast.
So A O E alpha plus beta 2 gamma E A beta beta 2 plus gamma. Got the two
Okay, Nana.
triangles.
So you draw the pictures and send it to me. Today I'm concluding the class and tomorrow we'll see that derivation part here. Okay.
Okay, sir. Okay, sir.
So today we learn just refraction of light at curved surface, but we need to practice the diagrams a lot. So the class is going to be ended within less than 1 minute. So tomorrow we'll wait. Nana. Bye, Nana.
Bye, sir. Thank you, sir.